the problems with this here. So 28, we're trying to find the number of positive, negative, and complex zeros. Guys, let's take it off for now. So to find the number of positive zeros, we're going to count the number of sign changes from one to the next. So if we look from x to the 7th to x to the 5th, that's 1. From the 5th to the 4th is 2. From the 4th to the 3rd is 3. From the 3rd to the squared, it doesn't change. From square to x, it does. And from x to our constant term, it does. So for the number of positive sign changes, we have 5. So it will have, at most, 5 positive solutions. Any questions on how we found the most positive solutions that this polynomial function can have? Now with this here, because we did one of these yesterday, and we went through and replaced x with negative x, and then anytime the power was odd, the sign changed. Anytime the power was even, it stayed the same, yes? Well, we could go back through and just look at each one here. So the first term is to the 7th power. 7th power is odd, so the sign will change from positive to negative. Yes. From x to the 3rd to x squared, did the sign change? So can we count it? Yep. So if we look at the next one, the 5th power is odd, so the sign will change from negative to positive. The next one we have is to the 4th power. 4th power is even, so the sign would stay the same. The one after that is to the 3rd power. 3rd power is odd, so the sign would change from negative to positive. The one after that is squared, so it's even, so the sign would stay the same. Because x by itself is to the 1st power. 1st power is odd, so it would change. And the constant term doesn't have anything happen to it. Now we can count the number of sign changes. So from x to the 7th to x to the 5th, there is 1. From x to the 5th to x to the 4th, there is not 1. From 4th to the 3rd, it doesn't change. From the 3rd to square, it doesn't. From the square to x, it doesn't. And from x to our constant term, it doesn't. So the number of negatives is 2. Guys, any questions on how we found this here? Yep, if the degree is odd, we do. If the degree is even, it stays the same. Now the most positive numbers we can have is 5. The most negatives we can have is, and we have a total of 7 solutions because the degree is 7. 5 and 2 does add up to 7, so we will have 0 complex. Now, I normally start with negatives and subtract 2 from each one till I can't anymore, and then subtract 2 from the positives. So we can subtract 2 from 2, which gives us 0. So our first set was that we could have 5 positive, 2 negative, and 0 complex. We could also have 5 positive solutions, 0 negative, and 2 complex. Can we subtract any more from the negatives? Well, no, it's at 0. But we can subtract from the positives. So if we subtract 2 from the positives, we can have 3 positives, 2 negatives, and 2 complex. Because again, in any one of these rows, it does still have to add up to be 7. 3 plus 2 is 5, plus 2 is 7. Now we can subtract 2 from the negatives, so we could have 3 positives, 0 negatives, and 4 complex, because it still needs to add up to be 7. Now we can't subtract any more from the negatives, but we can subtract 2 from the positives. So we can say we can have 1 positive, 2 negative, and 4 complex. And the last one is going to be 1 positive, 0 negative, and 6 complex. And that's our solution. Any questions on this here? Any questions on any of this so far? Let's look at the next set. The next and last set of problems is solving. And anytime we're solving these here, the first thing we'll do is graph. So we can grab the graphing calculator and hit y equals, and we can type the function in. So we'll say x to the fifth minus 20x to the third plus 20x squared minus 21x plus guys. So when we solve this here, the first thing we need to do is plug it into the graphing calculator and graph. Because again, we're looking for where it crosses the x-axis, where the y value is 0. And if we go second table, we see that it does give us 3 values, -5, 1, and 4. So those are 3 of the solutions that we have. So we can say x is equal to -5, 1, and 4. How many solutions should this have? 5. The degree is 5, so we should have 5 solutions. If it had given us 5, we would have been done. But we're looking for at least 3. Now at this point here, we can do synthetic division. So the numbers going across the top are going to be 1, 0 for x to the fourth, -20 for x cubed, 20 for x squared, -21 for x, and 20 for our constant term. Because we're going to reduce this down to a quadratic and then solve from there. Tyler. Now we need to pick one of these 4 solutions, or one of these 3 solutions to use to simplify it. It doesn't matter which one we pick. We could start with 1 and use it for synthetic division. Well, 1 times 1 is 1. 0 plus 1 is 1. Then we do 1 times 1 again, which gives us 1. -20 plus 1 is -19. 1 times -19 is -19. 20 plus -19 is 1. 1 times 1 is 1. -21 plus 1 is -20. 1 times -20 is -20, and 0. Guys. Now we're going to do this again. We're just going to pick one of the other solutions. So we could pick 4. Because each time we do this, we do decrease the degree by 1. So we can say 4 times 1 is 4. 1 plus 4 is 5. 4 times 5 is 20. -19 plus 20 is 1. 4 times 1 is 4. 1 plus 4 is 5. And lastly, 4 times 5 is 20, and -20 plus 20 is 0. Any questions on anything we've done so far? We're going to do this one more time with -5, because we're going to do this with each one of the solutions that we're given. Now when we do this here, -5 times 1 is -5. 5 plus -5 is? -5 times 0 is?
0.
1 plus 0 is? -5 times 1 is? And 5 plus negative 5 is?
0.
Any questions on how we got to this point here? Now, do we have any other solutions we can plug in? Well, no. So we can look at the equation that we have left. The 0 is the remainder. The 1 next to it is our term without x. 0 is the term with x, and the 1 is the term with x squared. So what that tells us is our current polynomial function is x squared plus 1 is equal to 0. If we don't have a middle term, we can use the quadratic formula, or the square root method to solve. Because we could use the quadratic formula or completing the square, but the square root method is the easiest one to use. And we can use it because we don't have a middle term. We don't have a term with just x to the first power. And the first thing we can do for this here is to subtract 1 from both sides. And if we subtract 1 from both sides, it'll tell us that x squared is equal to negative 1. At this point here, we can square root both sides. And if we square root both sides, square root of x squared is x is equal to plus or minus. So we have the square root of negative 1. So the square root of negative 1 by definition is 9. And so the solutions that we had are I, 1, 4, and that's it. Because we got 5 solutions, we needed 5. So that's all we need to do for that there. Any questions on this here? You ready for the next one? So the next equation we have is x to the 4th minus 6x cubed plus 7x squared plus 6x minus 8. How many solutions should we have? 4. So let's go on and graph it and see what we get. So we can say y equals, clear that out, so we can say x to the 4th minus 6x to the 3rd plus 7x squared plus 6x minus 8. And once we type the function in, we can hit graph, and we get this here. Now we can look at the table. So it tells us what values of x make the function 0? Negative 1, 1, 2, and 4. So it tells us x is equal to negative 1, 1, 2, and 4. How many solutions did it give us? How many are we looking for? Do we have them all? That's it. We have them all. Questions on this one here? So if we look at this next one here, how many solutions should we have? 3. So let's type it in and see how many it will give us. So we can say x to the 3rd minus 11x squared plus 41x minus 51. So we can type it in and hit graph. Well, how many zeros did it give us? 1. And that solution is 3. Because we're looking to see what value of x makes the y value 0. So one of the solutions for this here is that x is equal to 3. And we can use synthetic division because since it is a cubic, we needed 1. Awesome. You can just put it on my desk. Thank you. 1 for x to the 3rd, negative 11 for x squared, 41 for x, and negative 51. Now we needed to only really find at least 1, because if we have 1, then we can get it down to a quadratic and we could solve from there, guys. Now we do the synthetic division here. 3 times 1 is 3. Negative 11 plus 3 is negative 8. 3 times negative 8 is negative 24. 41 plus negative 24 is 17. And 3 times 17 is 51. And negative 51 plus 51 is 0. Now that we do have a quadratic, we can solve it from here. Because if we plug our variables back in, all right, guys, so we put the variables back in. 17 is our constant term without x. Negative 8 is our term with x, and 1 is our term with x squared. So it's telling us that our polynomial function that we have is x squared minus 8x plus 15 is equal to 0. Now, since we do have a middle term, we can't use the square root method, and the easiest method to use is going to be the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Or 17, thank you. 17. Now the first part we have is negative b. Well, what's the value of b? Well, we have negative b, so negative negative 8. The negative and negative make a. So we can just say 8 square root. So we'd have negative 8 squared minus 4. A in our case is, thank you. And C is 17. Over 2 times A. Well, the value of A is 1, and 2 times 1 is 2. All right, guys, let's focus in here. Guys, let's focus in here. Let's focus up here. Now we can plug everything inside the radical into the calculator. And it doesn't matter which one we use, so we can say negative 8 squared minus 4 times 1 times 17 and see what we get. And if we plug that in, it'll tell us that it is negative 4. Now we do need to see if we can simplify this here. Well, the negative inside the radical is going to come out as I, leaving us with the square root of 4. Well, the square root of 4 is? So we get 2I. Now we're both 8 and 2 divisible by 2. Yes. Well, 8 divided by 2 is 4, and 2I divided by 2 is just I. It wasn't 4. And that's it. That would be our solution. I do not know. I do not remember off the top of my head. Any questions on this here? Let's look at 33. And again, the first thing we'll do with any of these here, guys, graph it. When solving or finding all the solutions, the first thing to do is going to be to graph these. So we'll have 3x to the third plus x squared minus 38x plus 24. Graph. So we do see that it crosses the graph at 3 points. 2 of them look like they're nice numbers and 1 of them is not. Now, if we look at the table, we see that it does cross at -4 and 3. So we do have two nice spots that it crosses. Yep. You're welcome. So we do see two places that it crosses, yes? It is a degree 3, so we're looking for 3. We needed at least 1. So x is equal to 3 comma -4. So how many more solutions do we need? Just one. Now we know that the last solution is going to be real and it's going to be rational. Because if it was irrational, they have to come in pairs. We only have one other solution, so it can't be irrational. It has to be rational. And we can find it from here. Now looking across the top, we would have 3 for x to the third, 1 for x squared, -38 for x, and 24 for our constant term. Now we do need to pick between 3 and -4 which one we're going to use first. Doesn't matter which. So we could just start off with 3. Well, 3 times 3 is 9. 1 plus 9 is 10. 3 times 10 is 30. -38 plus 30 is -8. And 3 times -8 is -24. And 24 plus -24 is 0. And we already knew that it was going to be 0 because the graph told us that the y value when x is 3 is indeed 0. Now at this point here, we could stop and solve it by the quadratic formula or work that way there. Do we have another solution that works? -4. Because we can do this again. Because doing it once took it from a degree 3 to a degree 2. If I do it again, it's going to take it from a degree 2 to a degree 1, a linear. And it's going to make it even easier to solve. -4 times 3 is -12. 10 plus -12 is -2. -4 times -2 is +8. And 8 plus -8 is 0. Now at this point here, we can plug the variables back in. That's our remainder. Our -2 is our term without x, and 3 is our term with x. So really what that's telling us is that 3x minus 2 is equal to 0. Solve for the value of x. So I would add 2 first. Minus 3x is equal to 2. Then we can divide by 3, telling us that x is equal to 2/3. So these here are our 3 solutions. No. Somewhere around 100 to 200 a month. Probably. If I've seen, I think they had an online resource was sending students or sending people that way. This is the last one here. Actually, I did have one person comment on asking if one of these videos was Big Idea Math, the reviews, and they're not. So this is the last one we have here. How many solutions should we have? 3, because the degree is 3. So I would, again, start off by graphing. So we'll have 4x to the third minus 49x minus 60. And again, we're wanting to have at least one nice solution, one natural or integer solution. Because if we have one integer solution, we can take it from a degree 3 down to a degree 2 and either use the quadratic formula or some method for solving quadratics. Now we do see that at 4 we do get a value of 0. So we can use it. There were two other places that it crossed, but they weren't at nice numbers, so we're either going to get rational or irrational solutions. Now, here we can use 4 and set this up. And going across the top, we would have 4 for x to the third. Do we have an x squared term? No, so it would be 0. We'd have negative 49 for x and then negative 60. And again, for these calculations, you could use a calculator to do most of them. 4 times 4 is 16. 0 plus 16 is 4 times 16 is 64. Negative 49 plus 64 is 15. 4 times 15 is 60, and negative 60 plus 60 is 0. Now we can plug the variables back in. This would be our remainder. 15 would be the constant term, the term without x. 16 would be the term with x, and 4 would be the term with x squared. So what we have is 4x squared plus 16x plus 15 is equal to 0. Now we can use the quadratic formula at this point. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, the value of b in this case is 16. Because the number in front of x squared is a, the number in front of x is b, and the number by itself is c. And again, a, b, and c, the values for a, b, and c will not have a variable. None of them will. Because x squared and x are their own terms, a part of the equation. So negative b, so negative 16 plus or minus the square root of 16 squared minus 4 times a in this case is 4 and c is 15. All over 2a. Well, what did we say a was? A is 4, yes? What's 2 times 4? Now we need to figure out what 16 squared minus 4 times 15 is. And again, at this point, we can grab the calculator. And do 16 squared minus 4 times 4 times 15. And hit enter, and we get 16. And we're actually taking the square root of 16, which is going to eventually give us 4. So really what we're saying is that x is equal to negative 16 plus or minus 4 all over 8. Any questions on how we got to this point here? Do we have any radicals left over in this equation? Do we have any square roots left? No. Do we have any terms with I? So can we actually add and subtract these? Yeah. So we actually have two different equations here. We're saying negative 16 plus 4 over 8. And we also have negative 16 minus 4 over 8. And both of these are going to give us a value, yes? Well, both of these are just numbers. So in the calculator, we can hit fraction, negative 16 plus 4 over 8. Yes? Which is telling us it's negative 3/2. And instead of typing it all back in, you can go back and reselect it, highlight it, and hit enter. And it brings it back down. And the only real difference between these two is that the 4 is now negative. So negative 16 plus 4 over 8 is negative 3/2, and negative 16 minus 4 over 8 is negative 5/2. So we have negative 3/2 and negative 5/2. Those are the other two solutions. So that tells us x is equal to 4, negative 3/2, negative 5/2. We found all three, and we're finished. Any questions on any of these here? Now, if we wanted to check these values in the graphing calculator, we can. Because if you remember second trace, the first one we have is value. So negative 3 divided by 2. The calculator tells us that the y value is, indeed, 0. I can go second trace value, negative 5 divided by 2. And it again tells us that the y value is 0, which is what we wanted. Any questions over any of this here? Your test over this is tomorrow, end of the day.